Hello everyone, welcome to the 26th video on Snowpro core certification series. In this video, we are going to discuss about lot of things within Snowflake as the sequence on the Snowpro certification guide. This is the last section on the Snowpro core certification guide. Fortunately, we are going to end this series of videos soon. In this video, we are going to discuss about time travel, fail safe, zero copy cloning, replication, and how the data is getting encrypted within Snowflake. There are a lot of things to cover. Let us see how we can discuss about all these things. First, let us discuss about first future, which is called time travel. This is the future which we all want to have in our life, traveling back in time. Unfortunately, nature is not providing us with that option. But again, in Snowflake, we are having the option to do the time travel. As the name suggests, time travel is as simple as it is. You can travel back in time on your data in your table, and you can do whatever you want to do. So Snowflake's time travel enables accessing historical data. That is the data that has been changed or deleted at any point in time within a defined period. That is something which is very important to know. So what are all the things which you can restore? Restoring the data related objects, say like tables or schemas or like databases that might have accidentally or intentionally deleted. That is one of the use case for time travel, but predominantly we will be using time travel for the data corruption or some ETL load problems. Say if I'm loading the data via one ETL and that pipeline is having some issues with my data, so I can smoothly travel back before that ETL starting time so that I can reload the data again. So backup and restore, and also predominantly on the accidental delete. Say I dropped my table accidentally, then I can simply execute one single command, unwrap to retain the table again, right? Duplicating and backing up from key points in past, that is what which we discussed. Analyzing the data usage and manipulation over the specific periods of time. These are all the things which are possible using the time travel. This diagram again from the Snowflake documentation, this is very important. If you see, this is the continuous data protection life cycle. So standard operations happening on the data storage here, and then we can do the time travel. Here the retention is managed as 1 to 90 days, but again it is dependent on the version of the Snowflake, edition of the Snowflake which we are using. How we can do time travel is via different ways. One is using at and before. These at and before statements will be helpful for you to do the time travel. That can be added with the select statement and also can be added with the clone statement. Please wait for some time. We are going to discuss all the examples to a greater detail. And then there is another concept called failsafe. Again, in the same video, we are going to discuss about the failsafe in the greater detail. Now, to understand time travel, let us see a simple example. First, what we will do as the part of the life cycle of a table, we will do the create table statement. So, we will be creating a table. Once that is done, then what we will do, we will load the data into that table. Then maybe what we can do some updates on that table. Again, we will do some data loading on the table. So predominantly we will be doing these sorts of operations only: deletion, updation, inserting new records into table. These are all part of the typical ETL pipeline. Now we are on the current state meaning we are on this position. What is happened is we suddenly be able to understand there is a problem with the last data load. So the whatever the ETL pipeline which happened, which loaded the data onto the table, is having a problem. There is some amount of noise or some amount of invalid data got added to your table. Now what you want to do, you need to go back to that point before this data loading happened. That is what which we can do using the time travel. So from the current state, you can go back to the state before the specific data load. This is one of the very fascinating and interesting feature within Snowflake, which is very helpful for many of the operations. So using time travel, what are all the options which you can perform? So these are all the options which you can perform. Query the data in the past that has been updated or deleted. As simple as it is, that is what which we discussed using this diagram. Create clones of entire table, schema and databases at or before specific points in the past. So we are going to discuss about cloning in the same video. What is the zero copy cloning and all, but as simple as it is, utilizing the same option of at and before, we can do the cloning as well, meaning we can travel back in time and we can create one more additional copy of the data at that specific point in time. This is an evident use case which can be used across many use cases. Why? Because instead of changing the existing table, you want the copy of the table before the specific operation to see what is the exact problem. For comparison between the current table and the data before that specific point in time, there are a lot of use cases which we can solve using the cloning operation. Finally, we can do restoration for the schemas, tables and the databases that has been dropped. It is not an incidental delete or accidental delete. Say somebody who is having the superpower access, who is having the delete access, who is having the drop access, can do it accidentally, but with the help of this time travel as well, we can restore back the tables or schemas or databases which are dropped. Now we will see the time travel sequel, which are very helpful for us to do the time travel. Using at and before, as we saw in the previous diagram, we can use at and before statements along with the select statement and create clone statements to restore back the data. So what are all the options which you can specify in the at and before or a timestamp, meaning you want to travel back in time to that specific timestamp is possible. And the other one is the offset. Offset is the time difference in seconds from the present time. So for example, I want to travel back 1 hour before the current time. Those sorts of options are possible using offset. And finally, something called statement. If you are aware of the query ID which got processed, say I know this specific query is the problematic query, so simply you can specify the statement with the query ID and you can travel back before the query execution. And finally, the undrop command for the tables and schemas and the databases. Now we will see some of the important factors for time travel. In our previous videos as well, we discussed about these factors. Depending on Snowflake editions, depending on the table types, the time travel will vary. So for simple understanding, for standard edition of Snowflake, 1 day is the default time travel, can be set as the 0 as well. For enterprise edition and above, we will be having default 1 day of time travel for transient and temporary object, that can again be set to 0 as well. For permanent objects, we will be having 0 to 90 days. Please make a note, there is a mention of 0 in all the places. Here also 0, here also 0, here also 0, meaning what? You are disabling the time travel. If you want to disable the time travel, you can specify this option as 0. Some of the two important parameters, one is the data retention time in days object parameter that can be used by the users with the account admin role to set the default retention period for your account. So by setting this specific parameter to say like 30, we will be setting the time travel for the entire account for 30 days, meaning whatever the databases, whatever the schemas, whatever the tables which are associated with that account will be having the time travel of 30 days. Retention period is inherited, meaning if you set the retention at the database level, automatically that value will be inherited to schema, that will be inherited to table. As simple as it is. There is another important parameter which is minimum data retention time in days. This is again an account level parameter which is again set by the account admin role to set the minimum retention period for the account. This is the newer one. It is not available in the previous versions of Snowflake, but currently they added this parameter as well to set the minimum retention period. Now let us say some of the examples here. First thing is changing this specific parameter, data retention time in days. So what you can do, create table, my table. This is the table. At the table creation time itself, we will be setting the data retention time in days as 90, meaning you are setting the time travel option of 90, so you can travel back to 90 days, as simple as it is. Again, you can do the alter table as well for whatever tables which are already created. You can utilize the alter table command. Again, set the data retention time in days to 30. Here you are setting it to 30 days. By doing so, you can alter the data retention parameter. Coming to the important factor of how you can utilize the time travel, you can see all the options here. First is the timestamp option. Select star from my table, where I am going back in time using the timestamp. This is the very older example which is available in Snowflake documentation. So 2015 is mentioned. So similarly, you can add any of the date here. So for that specific timestamp, you are traveling back. And again, the offset which we already discussed, this is the 60 seconds, actually 60 into 5. So we are traveling back in time for 5 minutes, as simple as it is. And then, as we already discussed, this is a specific query ID. We are traveling back in time before this specific query got executed. So this is how we can utilize that using the at and also using the before statement. Predominantly, the before is used only with the statement parameter, not with the timestamp and with the offset parameter. Finally, as we saw, it is like the cloning option. So create table, restore table, clone my table at timestamp of specific period. So what it will do, at this specific timestamp, it will take the table and it will create a clone of the table in the name of the restored table. So the restored table will contain the data at this specific timestamp. So this is a very interesting feature you must be aware of. It is very helpful for you with respect to the backup, restore, undropping and other thing. Here is the undrop feature. So say if by accidentally if I deleted my table, simple single command, undrop table, my table, simple schema undrop schema, schema name, undrop database name. By executing only one statement, you can restore back complete table schema and also the database. Next, we are going to discuss about fail safe within Snowflake. We already saw this fail safe, but let us understand this. This is separate and distinct from time travel. Failsafe ensures historical data is protected in the event of system failure or other security breach event. Please pay more attention towards this specific statement. This is not the one which is used with the time travel. This is something very different and distinct from time travel. Please see this picture, the same picture which we saw. Here we are seeing the fail safe. So here there is a mention, we already know this, fail safe is 0 for a transient table. For permanent table, it is 7 days. No user operations allowed. Data recoverable only by the Snowflake. So please try to understand this. This is not something which we can do. This is only done by the Snowflake team. So this is a kind of a security mechanism which is available within the Snowflake system. Say if you are beyond the time travel retention, say I put 90 days of retention, but on 92nd day or 93rd day, I want to retrieve back my data for some reasons, say like for system failure or because of security breaches, then we can reach out to Snowflake and ask them to restore the data from the fail-safe period of 7 days. Again, please note, there are some important points to note. Non-configurable 7-day period. So maximum of 7 days alone, Snowflake will be helping you with the fail-safe mechanism, during which the historical data may be recoverable. Again, make a note, may be recoverable by Snowflake. There is no specific mention. It can be recoverable. It may be recoverable by Snowflake. This period starts immediately after the time travel retention period ends. Please make a note of this. Fail-safe is not provided as a means for accessing historical historical data after the time travel retention period has ended. You need to be very much aware of this. Don't take it for factor like failsafe is available, I can restore back my data even though if my time travel got ended. No is the answer. So it is not at all the option for you for the replacement of time travel getting the data back. It is only for very special scenarios, say like security breach or the system failure. It is used only by the Snowflake to recover the data that may be lost or damaged due to extreme operational failures. Please make a note of these statements. There are clear mention about the pointers here. That is the differentiation between the time travel and Snowflake. Data recovery through failsafe may take several hours to several days to complete. This is also very important to note. It's a kind of an failsafe mechanism, again as the name goes by, failsafe mechanism provided by the Snowflake in order to recover the data on extreme conditions. Non-configurable 7-day period which is available only for the permanent tables, as simple as it is. Next, we are going to discuss about cloning within Snowflake. Cloning, again, self-explanatory. The naming conventions used by the Snowflake are very self-explanatory for all these things. But we can call this cloning as another name, which is called as the zero copy cloning as well. Why it is a zero copy cloning? Snowflake never copies the data from one table to another table if you are creating the clones for that specific table. That is the reason why it is called as a zero copy cloning. It is a metadata only operation. Let us see how Snowflake is doing it. Snowflake zero copy cloning is the feature which provides a quick and easy way to create a copy of any table, schema or an entire database without incurring any additional cost, as the derived copy shares the underlying storage with the original object. As simple as it is, there is no extra cost for creating the zero copy clones. So it's a zero copy cloning. It creates a copy of the database objects without copying the data. That is the reason why it is called as the zero copy cloning, which is the metadata only operation. Cloned and the original objects are independent from each other. Again, an important point to note. Even though if you are creating the clone out of your original table, once the clone got created, it is completely independent of your original object. Until the changes of the cloned object shares the same storage as the original. Again, we are going to see this as the part of the detailed diagram. Any changes done on the cloned snapshot creates the additional storage component, which results in the additional cost. Now let us try to understand this via this good diagram from this thinketl.com. So now if you say table A is there, right? Table A is having the data. As you all know, the data in Snowflake is stored in the form of the micro partitions. So here if you see P1, P2, P3 are the three partitions on table A, that is stored on micro partition 1, micro partition 2 and micro partition 3 in the storage layer. Now if you create a clone out of this table A, say I am creating the table B which is clone of table A, what it does, it will create S1, S2, S3, which in turn uses the same storage of the table A. So there is no storage cost which is going to be added for you at the time when you create a clone. Now, as we already discussed, table A and table B are independent to each other. There is no dependency between A and B. Now, if I do some changes onto table B, what it does, say I am doing some changes on the table B on the S3 portion alone, which is the S3 partition alone, then what it does, it will create a micro partition for that specific portion alone. So S1 and S2 will be still using the micro partition 1 and micro partition 2 of table A, but the S3 alone will be using the new micro partition 4, which is created as the part of the load execution. Say you are doing some delete or some update or some data load, that will happen. So this is an interesting feature within Snowflake which helps you to store good amount of money using this specific zero copy cloning option. Again, this is very useful for varieties of use cases. One simple example example is like taking the production data for development environment. Say for the development environment, people to test these details, they need the access to the production data. As simple as it is, what we can do, we can take the production table and we can create a clone of that production table in the development environment, so that all the data in the production will be available to the users who are doing the development. As simple as it is, they can do their own as well, they can do edits, they can do the changes, but predominantly for only the changes they will be incurred with the extra cost. Now, clone inherits all granted privileges on the clones and all child objects contained in the source object. As simple as it is, if you are cloning the database, if you are cloning the schema, whatever the access which is there in your source table will be granted to the table which is cloned. Say if you are having role 1 which is having access to the table 1, if you clone the table 1 to table 2, table 2 will also be having the same access. The roles which are having the access to table 1 can access the table 2 as well. Internal named stages are not cloned. Again, the information you need to be aware of. Temporary and transient table cannot be cloned as the permanent tables. Again, temporary and transient tables can't be cloned. So now we will see how we can create a clone. It's a very simple operation. Here you can see create database mytestdb underscore clone mytestdb. As simple as it is. So this will create a clone of mytestdb in the name of mytestdb underscore clone. So again, similarly you can create a schema using clone. Similarly you can create a table using clone. One interesting feature, if you remember, as the part of the time travel as well, we discussed about cloning. We can combine cloning along with the time travel. That is what we are doing here. So we are creating a schema, my test schema underscore clone restore, which is the test schema before the specific timestamp. So we are traveling back in time and we are creating the clone of this test schema as underscore clone underscore restore. As simple as it is. So combinational option of time travel and cloning is always available. This is also helpful for you in varieties of use cases. Now we are going to discuss about another important feature within Snowflake, which is replication. Replication will be very helpful to you in the case of disaster recovery, business continuity types of the use cases. Again, name is self-explanatory. We are trying to replicate the data from one point to another point within Snowflake, but Snowflake supports lots and lots of good features that we are going to see as the part of the replication. First, let us try to understand the replication, how Snowflake is doing the replication. Replication of objects from source account to one or more target accounts in the same organization. First thing to note, within the same organization is the top in the Snowflake hierarchy. Within the organization, you can replicate the data from one of the account, which we call it as the source account, to one or more target accounts. Replicated objects in each target account as referred as secondary objects and are replicas of the primary object in the source account. As simple as it is. Again, the naming convention, whatever the replicated objects from primary will be stored in the other account, meaning the target account is referred as the secondary object. Replication is supported across regions and across cloud platforms. This is again very important thing to note. Let us see this diagram so that you can understand this in the better way. Here you are seeing we are trying to do the replication between AWS and Azure. AWS is the different cloud service provider, Azure is the different cloud service provider. Here you can see Acme provider account 1 is lying in AWS US West region, where our primary DB, this is our source account, primary DB DB1 is there, and we are creating the replication to Acme provider account 2, which is in completely different cloud service provider Azure in a completely different East US 2 region, and we are replicating the data to the secondary DB. So this is something which is very interesting. We are going to discuss about the share in the next video, so hold on for that. Now we are going to understand some other important factors. One is the replication group. Here if you see, the primary database which is part of the source account is part of something called as an replication group. A replication group is the defined collection of objects in the source account that are replicated as a unit to one or more target accounts. As simple as it is, replication groups provides read-only access for the replicated objects. Important thing to note, it provides only read-only access for the replicated objects. A failover group, here you can see this is the failover group, is the replication group that can also fail over. As simple as it is. So whatever it happens, right, when we created this replication, say if this one goes down, automatically it will be failed over to this specific account. That is the reason why I mentioned about disaster recovery and business continuity. The secondary failover group in the target account provides the read-only access for the replicated objects. Here as well, this will provide the read-only access alone. When the secondary failover group is promoted to primary failover group, read-write access is possible. Say for this scenario, if my primary goes down, I will promote my secondary to primary, then the read-write access is possible on my secondary too. Any target account specified in the list of the allowed account in the failover group can be promoted to serve as the primary failover group. This is an example. Here I mentioned only one target account. Instead, we can have multiple target accounts, so you can specify any of the target account in the failover group as the primary in the case of the failover. Non-replicated database objects are currently, as of May 2024, the temporary tables, external tables, hybrid tables and iceberg tables cannot be replicated. Important thing to note, temporary stages cannot be replicated. We didn't touch upon this specific concept. What is a temporary stage? A stage which is created, which is temporary, meaning it will be dropped at the end of the session. We can create that sort of stages as well by specifying the temporary command at the time of the stage creation. Within this temporary stage, we will be having two different stages. One is the external temporary stage and other one is the internal temporary stage. External temporary stage will drop the stage alone. The files will be existing in the external cloud storage. But if you are doing the internal temporary stage, automatically both the stage and the files will be dropped, as it is temporary in nature, which is tied to your session. Once the session got ended, everything will be dropped in internal temporary stage and only the stage will be dropped in the external temporary stage. Now we are going to discuss about some of the limitations within the replication. What are all the limitations? Databases created from shares cannot be replicated. Please hold on, we are going to discuss about shares to a greater extent in the next video. Refresh operations fail if the primary database includes a stream with the unsupported source object. The operation also fails if the source object for any stream has been dropped. Important thing to note, the refresh operations, the replication refresh will fail if there is a stream which is associated with the primary database is having the unsupported source object. I already saw what are all the unsupported source object, say like the transient table or iceberg table or temporary stages. Append only streams are not supported on the replicated source objects. We already discussed about what is the append only stream. Now we will see how we can enable the replication. What are all the sequence of steps which are involved for replication enablement? First thing, if you already enable the replication on your source database, we must have to disable the replication using one of the system function, disable database replication mydb. By doing so, the replication on mydb database will be disabled. Then we will create a failover group which is myfg for the objects of user, roles, warehouses, resource monitors and databases. Allowed databases are db1 and db2. Allowed accounts are my account 2 and my account 3, which is part of myarg. And then the replication schedule is 10 minutes, meaning it will do the replication once in every 10 minutes. Third step, you will be creating a failover group on your target account. We will be creating the primary failover group in your source account, and now we need to create the secondary failover group in the target account. In this case, we are trying to create it on the account number 2 or 3. Here we are specifying that my org account 1 as replica of my org, my account 1, my FG. This is the primary failover group which we are mentioning here. We are creating the failover group in the target account. And then what we can do, we can manually refresh the secondary failover group, which is the optional condition. Why? Because we already defined a 10-minute interval. Say I want to refresh the data immediately, then you can fire the specific refresh command, alter failover group myfg refresh in your target account, or else you can wait for 10 minutes. Automatically this replication will refresh the data. And then you can create another optional one. You can create the failover privilege on the primary failover group for the role. So here we are creating my failover role, for which we will be granting the failover on the failover group myfg. Again, it is the optional one. This specific role can be used for the further purposes. Now we are seeing the monitoring option. This is slightly different from the replication steps. How I can monitor my replication? Account replication history of the failover group myfg for last 7 days. We will be utilizing the replication group refresh history from the information schema. We will be taking all the details, start time, end time, total bytes, object count, everything for the interval of current date minus interval of 7 days. By doing so, you can see the replication history of the failover group in past 7 days. Finally, we are going to discuss about data encryption within Snowflake. We saw these details in our previous videos. We saw it very clearly. Snowflake stores the data in the encrypted way across everywhere. Whatever the data which is stored at rest in Snowflake is encrypted. Even the data in transit within the Snowflake is encrypted. These sorts of statements which we already saw. But now we are going to discuss in more detail about how Snowflake is doing the data encryption. First thing, end-to-end encryption is the method to secure the data that prevents the third parties from reading the data while at rest or in transit to and from Snowflake to minimize the attack surface. This is very evident. It is the security point of view. This needs to be enabled in any of the system. Here you can see two diagrams here. First, say customer provided staging area. If you are using you are a user in the customer end, and then you will be storing the data in the supported cloud storage staging area. This is the external stages here. Now, if you are placing the data, you can see the key symbol. Key symbol meaning everything is encrypted with this key. How the encryption works is as simple as it is. You will be utilizing the key. Using that key, you will be encrypting the data and you will store the encrypted data. As simple as it is. Here we are storing the data in the encrypted format in your supported cloud storage as well. And then you will be storing it in the Snowflake VPC in the encrypted format. Again, the retrieval of data happens in the same way. Everywhere if you see, the data is encrypted. 1, 2, 3, 4 is mentioned here. One is all about user uploads the data into stage, and then the user load the data from the stage to the table, and then user unloads the data from the table to the stage, and finally user will be downloading the data. This is how you can do using the external stages. Here if you are utilizing the internal stage, meaning the stages within the Snowflake, again the same principle is applied here. Whatever the data which is stored in the internal stage is completely encrypted, and whatever the data which is stored in the storage medium in the form of the tables is also completely encrypted. So for the encryption to happen, we understood that there is something called as a key which is needed. Snowflake is utilizing that specific key. So now the Snowflake, how it is doing the key management. Say, as we already discussed, key is the important thing. How Snowflake is going to do the key management for this data encryption, that is done using these specific ways. First is the root key. The root key is the one which is used to encrypt the root account, and then you will be having the account master key used to encrypt the account level, and within that account level you will be having the table master key, and then within that you will be having having the file key which is used to encrypt the data files. As simple as it is. So Snowflake manages the data encryption keys to protect your customer data. This is the hierarchical key model. As you see, there is an hierarchy here. One key is used to encrypt another key is used to another key. Like that way it goes on and on and on. So Snowflake is using AES 256-bit encryption with the hierarchical key model rooted in the hardware security module. Keys are automatically rotated on a regular basis by the Snowflake service, and the data can automatically be re-encrypted or re-keyed on regular basis. We are going to see this in a greater detail. Hierarchical key model, as you all know, several layers of keys in which each higher layer keys, which is the parent key, encrypts the layer below, which is the child key. Here, as you see, the data files are encrypted with table master, which is encrypted with account master, which is encrypted with the root key. This concept we call it as wrapping as well. Now we will see how Snowflake does the key rotation. There is a clear mention that Snowflake will be automatically rotating the key. Snowflake does that once in a month. So to understand this diagram, as you see the table master key version 1, right? This version 1 at the April is V1. Once the May got started, it will be rotated to V2. And then at the time of June, it will be rotated to V3. Once in a month, they will be rotating that specific key. We will see this to a greater detail. All the Snowflake managed keys are automatically rotated by Snowflake when they are more than 30 years old. Active keys are retired and new keys are created. Here on May, the TMK V1 will be retired and TMK V2 will be active. So very simple. When active key is used to encrypt the data and is available for usage by the customer, meaning if I am loading the data on month of May, then this TMK V2 only be used to encrypt the data. When retired, the key used solely to decrypt the data is only available for accessing the data. Let us try to understand this. Say in the month of May, I am just trying to access the data which is loaded on month of April. Obviously on month of April, that specific data is encrypted using this TMK V1. So what it does, for the May data, it will use the TMK V2, and for the April data, it will use the TMK V1, which is already retired. Now if you see for June, this is pretty easy. What it does, for the June data it will use V3, and for May data it will use V2, and for April data it will use V1. So only for the decryption of data it will use the retired key. For the newer data to be loaded, it will use the currently active key. As simple as it is. When wrapping the child keys in the key hierarchy or when inserting the data into the table, only the current active key is used to encrypt the data. This is what which we discussed to a greater extent. Finally, we are going to discuss about another important feature called tri-future or tri-secret secure. What is a tri-secret secure? We will try to understand. This is the tri-secret secure. So customers will be provided with the option to use their own key management service in the cloud platform. Example, AWS KMS in the AWS environment or Azure Key Vault in the Azure that host their Snowflake account to maintain their own additional encryption key. Typically, if you see in the previous diagram, there is only one root key there, but instead we can use two keys here. One is from our end, which is the customer managed key, and other one is the root key. So using two keys, we are going to manage the account master key, that is the composed AMK. Right? Instead of one key, we are going to use two keys here. That's the main thing. So the combination of Snowflake maintained key and the customer managed key creates a composite master key to protect the data. That is called as the tri-secret secure. As simple as it is, using two keys instead of one key. The composite master key acts as the account master key and wraps all the keys in the hierarchy. However, the composite master key never encrypts the raw data. I hope that is very evident. If you see, this is the hierarchy top level. So the composed key will be used to the encrypt the table master key, and then that is used to encrypt the file keys. So this specific composite key is not used for the raw data encryption which is stored at the file level. If the customer manager key in the composite master key hierarchy is revoked, your data can no longer be decrypted by Snowflake. That is the layer of security here. Say if this key is revoked, none of the data can be decrypted by Snowflake, because this key plays an important role as it is the composite key. Dual key encryption. Now we saw these two keys are used, and then the built-in user authentication within Snowflake, which provides 3 layer of security. That is the reason why it is called as secret secure. As simple as it is. With this we came to end of this video. As usual, I will be posting all the relevant Snowflake documentation links in the description of this video. Please go through these documents for the better understanding. I hope this video has been informative for you. Please do write lot of comments. That will be very helpful for me to enhance the course contents. Thank you very much for watching this video.